Verifying identities using double angles identities. We're going to do a following homework problem. Verify the following equation is an identity. Notice how we're using double angles here. I have a bunch of hints. On the right, hints, learn the double and fundamental identities. Substitute one of these identities whenever possible. Try starting with a more complicated side. So I'm going to stop there. Which side do you think is more complicated? I think it's cosine of 2x plus sine of 2x squared. Always try to simplify and factor. As you select your substitution, keep in mind the side that you're trying, the side you're not changing because it represents your goal. So to verify identity, that's what we're going to do. We're going to start with left side. We're going to use identities until we get to the right. Caution. I'm going to go over the caution next. The procedure for verify is not the same as solving, so I cannot subtract sine of 4x to both sides. Using techniques in solving such as adding, subtracting, and multiplying the same quantity each side does not work. Here are some notes. Sometimes if you get stuck, we'll talk about that in a few minutes, you can work on both sides. It's sometimes a good alternative. If one side is not effective, then do the other side. So if we work a little bit on this side and we don't get anything, I'll try the other side. Somewhere along the way, it may happen that both expressions occur, the same expression occurs on both sides. If that happens, pick one side and reverse each step that leads back to the other side. So those are the three notes that I have in general for solving identities. I actually have more on other pages. Okay, so what are we going to do? Well, it says to always simplify and factor, so I see a squared, so I'm going to think of simplifying, and I'm going to go for a FOIL. So I know that this is the same as cosine 2x plus sine 2x multiplied by the same quantity, cosine 2x plus another sine of 2x. So if I use FOIL, I know that that is cosine squared of 2x, the first, the outer, cosine of 2x times sine of 2x, and then this one times both, the inner. Oops, I'm running out of room. Could have just said two of those. Plus, just right over here for a second, sine squared of 2x. Because over here I'm going to rewrite this again. This time I'll have more room because this is going to be, right, the two middle terms are the same terms. They're the same term. And 1 plus 1, we know, is 2. So we get 2. It doesn't matter which one you use. I'll do sine of 2x, cosine of 2x. And now we have room for that sine squared of 2x. Okay, now I'm trying to get to this right side. Ooh, the 1 there. I see that. We know that sine squared plus cosine squared is 1. Let's write that. So if I just rewrite the sine with the cosine, we know this is 1. Again, let's write down what that identity is. We know that sine squared of theta plus cosine squared of theta equals 1. It doesn't matter what the theta is. So we know this is equal to 1. So I knew that goal because now I have that 1 there. If I can find 1, that's great. Okay, sine of 4x. What is that? Well, that's probably using the double angle because we know that sine of 2 theta equals 2 sine theta cosine theta. So I could change this to 2 sine theta cosine theta, but if you notice, my goal is that this is sine of 4x. It goes the other way around. So if I notice here, let's just do this in another color. If this is just as this theta is a 2x, this theta was a 2x, it still led us to 1. Well, if this is a 2x and this is a 2x, then this would be a 2x, and that would lead us to 4x. So this would tell us that sine of 4x we know is 2 sine of 2x cosine of 2x. So this right here, we know is 1 plus 2. Oh, not the 2. We use the 2 part of there as well, isn't it? This whole thing, whoops, I scrolled way too far, is equal to sine of 4x, which, by the way, is our right-hand side. So that did it. That is called verifying the identity.